Have you ever looked up at the sky on a cloudy day and wished you could make it rain? It sounds like something out of a science fiction movie, but it's a real technology that scientists have been working on for a very long time. This amazing process is called cloud seeding. It's a way for us to give clouds a little nudge, helping them to produce rain or snow when they might not be able to on their own. Think of it like being a weather magician, but instead of a magic wand, you use science. We aren't creating clouds from thin air, but rather working with the clouds that are already floating above us, encouraging them to share their water. So, what exactly are we doing when we seed a cloud? It's all about giving the tiny water droplets inside a cloud something to cling on to. Clouds are made of billions of super tiny water droplets or ice crystals, all floating around. Sometimes, these droplets are too small and too light to fall down as rain. They just hang out in the atmosphere, forming the fluffy white or gray shapes we see. Cloud seeding introduces tiny particles, called seeds, into these clouds. These particles act like a gathering point, helping the little water droplets team up and grow bigger and heavier until they are ready to fall. The idea isn't new at all. Scientists first started experimenting with this in the 1940s. A scientist named Vincent Schaefer discovered that he could use a substance called dry ice, which is frozen carbon dioxide, to turn supercooled water droplets into ice crystals. This was a huge breakthrough. It showed that humans could interact with the processes happening inside a cloud. Today, scientists have refined this method and use different substances, but the main goal remains the same: to help nature along and encourage clouds to release the precipitation that is already stored inside of them, just waiting for the right conditions to fall. This whole process is a fascinating example of weather modification. That's a fancy term for any activity that tries to intentionally change the weather. While we can't create a giant storm out of a clear blue sky, we can influence the behavior of existing cloud systems. It's a tool that can be incredibly useful in certain situations, like helping to fill up reservoirs with water, or even trying to reduce the size of hailstones before they can cause damage to crops. It's all about understanding the delicate science of clouds and giving them a gentle, helpful push in the right direction to make it rain. Let's break down how cloud seeding works step by step. First, scientists need the right kind of cloud. Not just any cloud will do. They look for clouds that are supercooled, which is a really cool state. This means the cloud is full of water droplets that are still liquid even though the temperature is below freezing, which is 0 degrees Celsius or 32 degrees Fahrenheit. These droplets are just waiting for something to trigger them to freeze. They have all the moisture needed for rain or snow, but they can't get the process started by themselves. It's like having all the ingredients to bake a cake, but forgetting to turn on the oven. Once the perfect cloud is identified, the next step is to deliver the seeds. The most common material used for this is a compound called silver iodide. The tiny crystals of silver iodide have a structure that is very similar to the structure of an ice crystal. Scientists can release these particles into the cloud in a couple of different ways. Sometimes, they use special cannons on the ground that shoot the particles up into the air. More often, they use airplanes equipped with special flares on their wings. The planes fly directly through the supercooled part of the cloud and release the silver iodide particles right where they are needed most. This is where the magic of science really happens. The supercooled water droplets in the cloud are tricked by the silver iodide particles. Because the silver iodide crystals look so much like ice, the water droplets rush to attach to them. This process is called nucleation, which is just a scientific word for forming a nucleus or a central point. As soon as the water droplets touch the silver iodide seeds, they instantly freeze and become tiny ice crystals. This starts a chain reaction inside the cloud, as more and more water droplets find a seed to freeze onto, creating a growing number of ice crystals. Now, we have a cloud full of growing ice crystals instead of tiny water droplets. These ice crystals are heavier than the water droplets were. They start to attract even more moisture, growing bigger and bigger through a process called accretion. Imagine a small snowball rolling down a hill and picking up more snow. That's what's happening inside the cloud. Eventually, these ice crystals become so big and heavy that the cloud can no longer hold them up against gravity. They begin to fall from the sky. If the air below the cloud is cold, they fall as snow. If the air is warmer, they melt on their way down and fall as rain. So, why do people want to make it rain in the first place? One of the biggest reasons is to fight against drought. A drought is a long period with very little rainfall, which can be very bad for farming and for making sure cities have enough drinking water. Many dry places around the world use cloud seeding to try and increase the amount of rainfall they get. For example, in the western United States, states like California, Colorado, and Utah have used cloud seeding for many years. They use it to increase the amount of snow that falls in the mountains during the winter. This snowpack acts like a natural reservoir, melting in the spring and summer to fill rivers and lakes. Another important use for cloud seeding is to support agriculture. Farmers depend on rain to grow the food we all eat. In areas where rainfall can be unpredictable, cloud seeding can be a lifeline. Countries like China and India have large-scale cloud seeding programs to help their farmers. By encouraging more rain to fall over farmlands, they can help ensure a better harvest and prevent crop failures. This is incredibly important for feeding a large population. It's a way to provide a little bit of water security in places where the weather doesn't always cooperate with the growing season. Cloud seeding isn't just about making more rain or snow. It can also be used for other fascinating purposes. In some places, it's used to try and suppress hail. Large hailstones can destroy crops and damage property. By seeding storm clouds early, scientists hope to create many small, soft hailstones instead of a few large, destructive ones. Another interesting use is to clear away fog. At airports, thick fog can prevent planes from taking off or landing. By seeding the fog, which is just a cloud on the ground, they can turn the tiny water droplets into light drizzle or ice crystals, improving visibility and allowing the airport to operate safely. Before major events, some countries have even used cloud seeding to ensure good weather. Perhaps the most famous example of this was during the 2008 Beijing Olympics. The Chinese government launched a massive cloud seeding operation in the days leading up to the opening ceremonies. The goal was to make clouds rain before they reached the city, ensuring a clear and dry sky for the big event. This shows how cloud seeding is viewed as a powerful tool, not just for resources like water, but also for managing local weather for specific purposes, demonstrating a high level of control over the environment. While cloud seeding sounds like a perfect solution, it comes with some big challenges and questions that scientists and policymakers are still thinking about. One of the biggest difficulties is proving that it actually worked. How can we be sure that a seeded cloud wouldn't have rained anyway? It's very hard to know exactly how much more rain or snow fell because of the seeding. Scientists try to study this by comparing seeded clouds to similar, unseeded clouds. But weather is so complex and chaotic that it's tough to get a perfect measurement. This makes it hard to say with 100% certainty how effective each cloud seeding project is. Another major concern is about the environment. The most common seeding agent, silver iodide, is released into the air and falls to the ground with the rain or snow. Although it is used in very small amounts, some people worry about the long-term effects of adding this substance to the soil and water systems. Scientists have studied this for many years, and most research shows that the levels are too low to be harmful to humans or most ecosystems. However, it's a question that requires ongoing monitoring to ensure that we are not accidentally causing a different kind of problem while trying to solve another. There are also legal and ethical questions to consider. If you make it rain in one place, are you stealing rain from a neighboring town or country downwind? This is sometimes called the rain shadow effect, where one area's gain could be another's loss. Imagine two farms next to each other. If one farmer pays for cloud seeding and his crops get water, but his neighbor's clouds seem to disappear, it could cause serious conflicts. As cloud seeding becomes more common, Countries and states will need to create rules and agreements about who owns the water in the clouds and who has the right to change the weather. In summary, cloud seeding is an incredible scientific tool that allows us to give nature a helping hand. By introducing tiny particles into the right kind of clouds, we can encourage them to release their moisture as rain or snow. This is used around the world to fight droughts, help farmers, and even clear fog. However, it's not a perfect science. We still face challenges in proving its effectiveness, understanding its environmental impact, and figuring out the fair way to use a technology that can move water from one place to another. It shows both our amazing ability to understand the planet and the great responsibility that comes with that power.